Hello students, now welcome to my online class. Myself Firoz Sheikh, and today we are going to start a new chapter number 1, rational number. What is rational number? So before starting with the rational number, we will have a quick recap over this. This one, natural number. What is whole numbers? Okay. And lastly, before going to rational number, we will talk about integers. Okay. So what is a natural number? It's very simple. All counting numbers are what? A natural number. Just like 1, 2, 3. Suppose we have to count some items over a table. So from where we will start? We will start from 1. So 1 item, 2 item, 3 item, like this. So all the counting numbers are known as what? Natural number. Let me show this thing in the number line. Okay, this is our number line. Suppose this one is our 0, 1, 2, 3, 4, 5, and up to plus infinite times. Okay, on the left hand side, -1, -2, -3, -4, -5, and up to minus infinite. Okay. Now the numbers in a number line, here we can say from 1 to positive infinity. As long as we can count, those numbers are known as what? Natural number. So we will call it like as a natural number. Natural numbers. So from 1 to, as long as we can count. Okay. So natural number. Now if we include 0, and natural number, it is known as what? Our whole numbers. Is that clear? It's very simple. 0 including natural number becomes a whole number. Now what about integers? All the numbers in a number line, means the positive numbers, 0, and the negative numbers, all are what? Integers. Okay, it means integer includes natural number also, whole number also. Is that clear? It's very simple. Now we will come to the topic, our rational number. What is rational number? A number which can be expressed in the form of P by Q. Okay, where P and Q are integers. P and Q are integers. It means P can be a positive number, 0, or negative number, and Q also, it may be a positive number, negative number, but one condition is given, that a number which can be expressed in the form of P by Q, where P and Q are integers, but Q is not equal to 0. It can't be equal to 0. Then only we can say that P by Q is a rational number. So the number which can be expressed in the form of P by Q, in the form of fraction, okay, where P and Q both are integers. Only one condition is that the Q, the denominator part, can't be equal to 0. Okay, so we can say that all the numbers in the number line, okay, whether it is positive number, whether it is 0 or negative of the natural number, are rational number. How? Let me show you. See, if I write 1 by 1, the value of 1 by 1 will be 1, no value changes, but it looks like the form of P by Q, so it is a rational number. 2 by 1, the value doesn't changes, 2 by 1 equal to 2, and 2 by, it looks like P by Q form, 2 by 1, so it is a rational number. So if I put 1 at the denominator of every number, okay, all are what? Rational number. So we can say that all whole numbers, all natural numbers, or we can say all integers are rational number in this form. Is that clear? Now if I write, suppose 5 by 0, then in this case it is not a rational number. Why? Because here our Q shouldn't be equal to 0, but we have written 5 by 0. That's why this form of a fraction will never be a rational number. So we can say that P and Q both can take the positive value and negative value. Only P can take the value of 0. So if I write suppose 0 by 5, then it is a rational number, because P is also integer as mentioned here. P and Q are both integers. Only condition is that Q can't be equal to 0. So here it is 5. So it is 0. So this type of number is our rational number. So I hope you have understood this part, and we will talk about some properties of this one. Let's come to the next topic. Yes. Now come to the next property, means next topic, properties of the rational number. First we will deal with the closure property. What is closure property? Actually closure property says that, means suppose we add to a natural number, the result will be natural number. Then we can say that the natural number is closed under addition. Okay, if we subtract two natural number, if we get a natural number, then we can say that the natural number is closed under subtraction. For example, suppose 6 is a natural number, 2 is a natural number, so 6 plus 2 equal to 8, so 8 is a natural number. So ultimately we can say that the sum of the two natural number gives a natural number. Then we can say that it is closed under addition. Same thing we will deal with the rational number. So in this closure property, we will go for only 4 proportions. First one is we will check in addition, we will check in subtraction, we will check in multiplication, and we will try to check in division. So let's take first example of addition. Okay, if we take A by B plus C by D is equal to a rational number. Okay, then we can say that the sum of the rational number, or we can say it is closed under, the rational number is closed under addition. Let's take an example. Suppose 2 by 7 plus 3 by 7. If we take LCM 7, 2 plus 3 gives you 5 by 7. Ultimately 5 by 7 is also a rational number. Here 2 by 7 is a rational number, 3 by 7 is a rational number. Ultimately we get the result a rational number. So we can say that rational number is closed under addition. So the addition we can give tick mark here. Now let's talk about subtraction. Suppose A by B minus C by D is equal to, whether we are getting rational number or not, we will check rational number. Okay, let's take an example. Just now the same example let's take. Suppose 3 by 8 minus 2 by 8. So if we take an LCM 8, 3 minus 2 gives you 1 by 8, or we can say 2 by 8 minus 3 by 8 gives you 2, minus 3 by 8 gives you minus 1 by 8. In both cases, see, the higher value minus lower value, then also we are getting 1 by 8, means P by Q form rational number. So subtraction of two rational number gives a rational number. Here in this case also smaller value minus greater value, then also we are getting a rational number. So it means the rational number are closed under subtraction also, means whenever we subtract two rational number, always we are getting a rational number. So this is also justified. Okay, now come to multiplication. The third proportion we will check, multiplication. Okay, A by B into C by D, whether we are getting a rational number or not. Let's check it. Okay, let's take an example. 4 by 9 into suppose 3 by 8 equal to, whether we are getting or not, let's see. 4 2 9, 3 3, 3 3 9. Ultimately we are getting 1 by 6. So multiplication of two rational number also gives you a rational number. Let's take another example. 2 by 6 9, 2 by, let's take another 7 into 0 by 5. Here also if you multiply 2 0 is 0, 735. 0 by 35 is also a rational number. Ultimately, we can say that in multiplication also, if we multiply two rational number, we are getting result as a rational number. So we can say that the rational number is also closed under multiplication. Okay. Now come to the topic division. Division. A by B is divided by C by D. Whether we are getting a rational number or not in all the cases, we will check. Okay. Okay. Let's take an example. Just like 2 by 7 divide 8 by 21 equal to 2 by 7 into 21 by 8. We know how to do division here. Okay. 2, 4, 7, 3. Ultimately, we are getting 3 by 4. So, in this case, we are getting 3 by 4. 2 by 7 divided by 8 by 21. Both are rational number. And we are getting result 3 by 4. That too is a rational number. So, in this case, till now we can say that rational number are closed under division. But let's take another example. Same thing, 2 by 7 is divided by, suppose 0 by 21. Now if I try to solve this one, 2 by 7 into it will be 21 by 0. Ultimately 42 by 0. And I already explained in earlier classes that P by Q can't be equal to 0. The denominator can't be equal to 0. So ultimately, in this case, we are not getting a rational number. Then you can say we can't define this thing. So, in case of addition, we can say the rational number are closed. Addition means addition of two rational number always gives you a rational number. In case of subtraction of two rational number gives you always a rational number. In case of multiplication also, if you multiply two rational number, always you will get a rational number. But in case of division, you are not getting a rational number always, because sometimes you may get a rational number, sometimes you can't define the number. So in this case, we can say that rational number are not closed under division. So I hope you have understood this part. Let's come to the next topic. Our next property is commutativity. What is commutativity? Let me show you example. Suppose A plus B is equal to B plus A. If this justifies, B plus A, both the parts are equal, then this form of expression we can say the commutativity. Okay. Now let's do the example. As I told you, all the properties we will check in 4 phases: for addition, for subtraction, for multiplication, and for division. So let's start with the addition. Add. Okay. A by B plus C by D must be equal to C by D plus A by B. Let's take an example. Suppose 2 by 3 plus 1 by 3. Here also 1 by 3 plus 2 by 3. I'm taking small examples so that it will be easy for us to calculation. So very simple here. 3, 2, make it easy 8. It looks a little bit odd here. And make it a 3. So 8. 3 plus 1, here also 1 plus 3 by 8. Ultimately we are getting 4 by 8. Here also we are getting 4 by 8. The both parts are equal. So we can say that in commutativity addition is applicable. So in commutative property, rational number are closed under addition. So here in this case, we can give a tick mark. It says that for rational number, the commutativity for addition is applicable. Now come to the subtraction part. Let's see whether we are getting the result or not. In subtraction, A by B minus C by D Whether it is equal or not, we will check C by D minus A by B. If it is equal, then we can say that for commutativity, rational number are closed under subtraction. If it is not equal, then it is not closed under. Okay. Now let's take an example. Suppose 2 by 5 minus 1 by 5. 1 by 5 minus 2 by 5. Let's see whether these two parts are equal or not. Here we are getting 2 minus 1 by 5. Here we are getting 1 minus 2 by 5. In this case we are getting 1 by 5. Here also we are getting 1 by 5, but it is minus 1 by 5. So here we can see that both the magnitudes, means 1 by 5, 1 by 5 we are getting, but the sign is different. On the left hand side we are getting a positive value, and right hand side we are getting a negative value. So left hand side means A by B minus C by D is not equal to, we can say is not equal to C by D minus A by B. So in commutative property, rational number are not closed under subtraction. Okay, now come to the multiplication. Now we will deal with the multiplication. Multiplication. Here A by B into C by D, whether it is equal to C by D into A by B or not, we will check. Let's take an example. 3 by 7 into 2 by, suppose 5. Here 2 by 5 into 3 by 7 or not. Let's see here. 2 into 3. 3 2 just 6. 7 5 just 35. Here also 3 2 just 6. And 5 7 just 35. So in this case we can see both the sides, left hand side and right hand side, are equal. 6 by 35, 6 by 35. So we can say that in commutative property, rational number are closed under multiplication. So we can give a tick mark, means it is applicable in multiplication. Now come to the division part. Let's see whether it is applicable or not. In division, A by B is divided by C by D. Whether it is equal to or not, let's see. C by D is divided by A by B. Let's take an example. 2 by 3 is divided by 5 by 7. And 5 by 7 is divided by 2 by 3. Let's see. In this case, we will get 2 by 3 into 7 by 5. Here we are getting 5 by 7 into 3 by 2. So in this case, how much we are getting? Let me write here. 7 2 ja 14 and 5 3 ja 15 is equal to, let's see whether it is equal to or not. 5 by 7, 3 by 2, 5 3 is 15, answer is 14. So we clearly say that the left hand side is not equal to right hand side, because in left hand side we are getting 14 by 15, on right hand side we are getting 15 by 14. So in commutative property, rational number are not closed under division. So we can say that the commutativity is not applicable in case of division for a rational number. Okay, so it is not equal to left hand side. So ultimately we can say that in a commutative property, the rational numbers are closed under addition and in multiplication, whereas in subtraction and division, this commutative property is not applicable in these two cases. So I hope you have understood this part very nicely. Now come to the next topic. Our next property is associativity. So in associativity, generally we used to deal with three numbers. For example, suppose A plus B plus C. If we add first these two numbers A and B, then we will add C. Whether it is equal to A plus B plus C or not. Suppose if we add first in the left hand side, if we add two numbers A plus B first and then we will add C. On the right hand side, if we add first the second and third number first and then with the first number, if both the results are equal, then we can say that associativity is applicable in case of addition. Okay, the same way we will deal with subtraction also, we deal with the multiplication and division for a rational number. So let's start with the addition. First, addition. Okay, so I'm not going to put any example, simply I will tell you in which cases it is applicable, in which cases not applicable. Okay, in addition, suppose A by B plus C by D plus E by F. If we, let's take, we will add first, second and third number, and then we will with the first number. A, we will get whether A plus B by A plus B plus C by D plus E by F. So in addition, for associativity of a rational number, it is applicable. Means when, if we add first, second and third number first and then add with the first number, the whatever result we will get, same result we will get in this case also when we add first and second number first and then we will add the third number later on, the result will be same with the left hand side also. So it is applicable in addition. So in associative property, rational number are closed under addition. Okay, but in case of subtraction, suppose A by B minus C by D minus E by F is not equal to A by B minus C by D minus E by F. In subtraction, it will be not equal to, the left hand side is not equal to the right hand side. Means in associativity, the rational number is not closed under subtraction. If you try, if you can put some examples over here and you can find it by yourself. Okay, so now come to the multiplication. In multiplication, if you multiply A by B into C by D into E by F, the left hand side will be equal to A by B into C by D into E by F. Okay, so in case of multiplication, you will see that the left hand side, that is the multiplication of second and third number first, and then we will multiply with the first one, the result, whatever result will come, it will be equal to the result of this one also. Means that when we multiply first and second number first and then multiply the third number later on, the result will be same. So it is applicable in multiplication. So in case of associative property, rational number are closed under multiplication. So here it is closed under multiplication. Now what about division? In division, A by B is divided by C by D is divided by E by F is not equal to A by B is divided by C by D is divided by E by F. So in case of division, you will not get the result here. Means it is not applicable. The associativity or associative property is not applicable in division for a rational number. So in case, so we can say that for associative property, rational numbers are not closed under division. It is only closed under addition and subtraction. And for subtraction, addition and multiplication, and for subtraction and division, it is not applicable. The associative property is not applicable for a rational number for subtraction and division. So I hope you have understood this part very nicely. Now come to the next topic. Now our next topic is, the property is distributivity of multiplication over addition. For example, let's take example A is multiplied by B plus C. How we will write this one? We will write, first we will try to multiply A with B, then there is an addition sign is there, and then we will try to multiply A with C. So A into B plus A into C. In this way we will write. So this is what? Distributive property of multiplication over addition. If we put subtraction also here, suppose minus, the case will be same. A into B minus A into C. The both part will be equal. Now let's take an example for the rational number. Okay. In rational number, suppose 4 by 3 is multiplied by suppose 2 by 7 plus we can take 5 by let's take an example 3. Okay, now what will be the result? As I told you, first we will multiply these two. Okay, first we multiply with this first number, then plus with the second number. So 4 by 3 into 2 by 7 plus again 4 by 3 into 5 by 3. So this is the distributive property of multiplication over addition. Now if we put subtraction here, 4 by 3 here, 2 by 7 minus 5 by 3, here also what? 4 by 3 into 2 by 7 minus 4 by 3 into 5 by 3. So in both the cases, after solving, you will get that the result of the left hand side will be equal to right hand side for addition. So in that case, we will say that distributive property of multiplication over addition, and in case of subtraction also, you will get the same result on left hand side equal to right hand side after solving this one. So I hope you have understood this part. It's very easy. Now come to the next topic. So our next properties are additive inverse and multiplicative inverse. It's very simple. First we will deal with the additive inverse. Additive inverse means what? Suppose a number we have a, the additive inverse of a will be minus a. Simply we have to change the sign. If it is positive, then we will write as a negative sign. For example, suppose for a rational number 2 by 3. So additive inverse of 2 by 3 will be equal to how much? Minus 2 by 3. Okay. So it's very simple. Simply we will change the sign. So sum of the rational number to its additive inverse will be always 0. Means 2 by 3 plus additive inverse of 2 by 3 gives you 0. So that is what? 0 is the additive identity of this one. Okay. So whenever we add a rational number to its additive inverse, we always get a 0, because see here 2 by 3 it will be minus 2 by 3. So 2 by 3 minus 2 by 3 always gives you 0. So 0 is what? Additive inverse. Okay. So additive identity. Okay. Now we will talk about multiplicative inverse. In multiplicative inverse, if a by b is the rational number, the multiplicative inverse will be b by a. That is, we can say that the reciprocal, or we can say reciprocal. Okay. So the multiplicative inverse of a by b will be a by b will be b by a. Let's take an example. Suppose 2 by 3. What will be the reciprocal of, or you can say multiplicative inverse of 2 by 3 will be 3 by 2. Take an example. Suppose 5. The reciprocal of, or you can say multiplicative inverse of 5 will be 1 by 5, because there is nothing under 5 except 1. So 5 by 1 is 5. So we will inverse this one. So it will become 1 by 5. So this is known as what? As multiplicative inverse. So in case of additive inverse, the addition of both the numbers, the number and the inverse, is always 0. And in case of multiplication inverse, the multiplication of the number to its multiplicative inverse, to its reciprocal, will be always 1. For example, let's take 2 by 3, okay, into to its multiplicative inverse, that will be 3 by 2, gives you always 1. If you multiply, this will be cancel it out, ultimately you will get 1. So in additive inverse, the number, whatever number we have, we will simply change the sign, and in case of multiplication inverse, simply we will take the reciprocal of that number, or we will shift the numbers. In suppose a by b, here a is in numerator and b is in denominator. In case of multiplicative inverse, when we try to find the multiplicative inverse, we will simply shift the value of denominator to the numerator place and the value of numerator to the denominator place. So a by b, the multiplicative inverse of a by b is b by a. So I hope you have understood this topic very nicely. Now come to the next property. Now our last two properties are, first one is the representation of rational number on number line, and lastly rational numbers between two rational numbers. So let's deal with first topic, the representation of rational number on number line. Let's take an example. Example 3 by 7. Now we have to represent this rational number 3 by 7 or on a number line. So let's take a number line here. Okay. Now as because it is a positive rational number, so it will be on the right hand side of the 0. So we can start from here 0. You can start from in this direction. Suppose if would have a negative, so we put a negative sign, then it will be on the left hand side of the 0. Let's take another example. 2 by 5 minus 2 by 5. So for this example we will show later on. First let's do this one. Now 3 by 7 on a number line. Now how we will plot this 3 by 4 on a number line? So first we will check the denominator. Here denominator we can see is 7. So our denominator is here is 7. So our one unit, suppose 0 to 1, 1 to 2, 2 to 3, each unit will be divided into 7 small divisions. So let's see how we will do. 0, then 1, 2, 3, 4, 5, 6. On 7 we will have our 1. Again 1, 2, 3, 4, 5, 6. On 7 we will have our another unit 2. So on, in this way we will move on. Okay. Now there are small divisions are here, and how many divisions we have? 7 divisions. So one division will be out of 7, so it will be 1 by 7. So we can write this is 1 by 7. This will be our 2 by 7, and this will be our 3 by 7. So in this way, so we can show in a number line 3 by 7, then 4 by 7, 5 by 7, 6 by 7. This is 7 by 7 gives you 1, ultimately 8, 9, 10 by 7, 11 by 7, then 12, 13, then 14 by 7, 14 by 7 gives you 2. So whenever you try to plot a rational number on a number line, please go through the denominator first, and according to the denominator we will try to divide our each unit. Here it is 7, so our each unit is divided into small 7 divisions. Each unit is divided into small 7 divisions. Now let's talk about this negative rational number. Minus 2 by 5. Let's draw a line here. It is minus 2 by 5, so it is a negative rational number and it falls on the left hand side of the 0, so we will write 0 on the right hand side. Now again we will see here denominator 5. So for each unit we will have small 5 divisions. So for this one we will write 1, 2, 3, 4. On 5 we will have our first unit 1. Then again 1, 2, 3, 4. On 5 we will have our second number minus 2, like this. So in this way we keep on continuing dividing our each units. Now minus 2 by 5. So this small division will be 1 out of 5 divisions. So 1 by 5, 2 by 5, 3 by 5, 4 by 5. It is 5 by 5. Minus 5 by 5 gives you 1. So here minus 2 by 5, this will be minus 2 by 5. 1 by 5, 2 by 5. This will be minus 2 by 5. So it is easy to represent a rational number on a number line. Just you need to keep on mind that whether it is positive or negative. If it is positive, then try to keep the numbers on the right hand side of the 0, and if it is negative, try to plot the number on the left hand side of the 0. And second one, you need to see whether the denominator is, what is the value in the denominator. According to that, you will keep your divisions for each unit. Okay, so I hope you understood this part, representation of a rational number on a number line. Now come to the next part, rational numbers between two rational numbers. Okay, now let's take an example. Let's take an example. Suppose 2 by 3 and 1 by 4. Two rational numbers we have. And let's find two rational numbers in between these two rational numbers. So Before finding this one, first what we need to do, we need to find LCM of their denominators with the base 3 and 4. So LCM of 3 and 4 is how much? Definitely it will be 12. So we will try to convert this one. 2 by 3 is 3 into 2 into gives you 12. So it will be 4. So it will be here also 4. 4 to 8. 8 by 12 and 1 by 4. Here also 4 into 1 into is 12. So 3. So 3 by 12. So we can clearly find out so many rational numbers. See, 3 by 12 and 8 by 12. We have a lot of rational numbers in between this. 4 by 12, 5 by 12, 6 by 12 and 7 by suppose 12. So in this way we can find a lot of rational number between two rational numbers. Now let's take another example. Suppose rational number between 2 and 3. Suppose 2 and 3. So right now these looks like a whole number or an integer or a natural number. So 2 by 3 and 1 by 3 means what? 2 by 1 and 3 by 1. Am I right? Okay. Now we need to find, suppose 4 rational number. So we need to find 4 rational number. So 2 by 1, 4 rational numbers, we will multiply it by 5. So how much we are getting? For the 10 by 5 and this one 5 into 5 gives you 15 by 5. So in between 10 and 15, 10 by 5 and 15 by 5, we will have, see, 11 by 5, 12 by 5, 13 by 5 and 14 by 5. See, exactly we have 4 rational number between 2 and 3. So I hope you have understood this one also very nicely. So I think you can do whatever question comes, you can do it by yourself. Thank you.